to another edition of Math with Taebyn. I am Taebyn. I'm a pup, bark bark. One of my other videos, I talked about partial fractions, where in the denominator you had just a product of linear factors, so first degree things. Here, I want to just tell you how to set up other cases. So there's 4 cases. The first case was linear factors. This stands for partial fraction decomposition with linear factors, so I'm going to assume you understand how that works, because then these other cases work really exactly the same idea. So you've got the linear thing, 4 cases. You have the linear factors, and so that's my other video. This is other, I can't write with my pauses. You could have repeated linear factors. For example, you could have in the denominator x plus 1 cubed times 2x plus 1 or something. So you've repeated this factor 3 times. So you could have quadratic factors. So that's second degree things. So for example, you might have x squared plus 1. And these are irreducible, so not factorable. Times, 2x squared plus 4x minus 2. I'm just making that up. And you could have 2 maybe on the top, I don't know. Quadratic on the bottom. And then of course you could have repeated quadratic. And again, I want to point out that these are irreducible. It means not factorable over the reals, and so like not complex number stuff, but basically, so like x squared plus 1, it's stuck like that unless you introduce complex numbers. X squared minus 1 you could factor, so that would actually fit in the linear case. Let me show you the basic setup of these. So let me talk, if you have, for example, cubed times 2x minus 3. For each repeated factor, you have another fraction where you're increasing the degree of the denominator. So for example, I have 3 of these x plus 1. So I'm going to have an x plus 1. I'm going to have an x plus 1 squared. And then I have an x plus 1 cubed. And then I have this 2x minus 3. And then they're linear. I mean, the actual factor themselves are linear. So I'm going to do just like I did in the other video. These will be numbers. And then you proceed exactly like I showed in the other video. You clear the fractions, multiply both sides by this denominator, plug in numbers for x that work, and you can solve for a, b, c, and d. So let's go on to the next case, quadratic factors. So for example, you might have, I'm just going to make something up here. Maybe I'll throw in a linear thing too, just for the fun of it. You're still going to do like you did before, and for each factor, you're going to have another fraction. And this x minus 3. Now, when you have a quadratic, irreducible, meaning you can't factor this with real numbers. Instead of just a number, you go up to a linear thing. So you have an a x plus b. And then this is linear, so it's just a c again. That's all there is to it. And then you have to solve for a, b, and c. So just let me go through really quick like you would normally do. Multiply both sides by the denominator. Again, I'm assuming you understand this stuff from my other video about the linear factors. I'm just doing that again. That's why I'm going kind of fast through this part, because hopefully you understand that. See, if I multiply this by the denominator, the x squared plus 1 goes away. And I'm left with plus b times x minus 3. And then I have the x minus 3 part goes away. x squared plus 1. That's an x. X. And then, you can plug in a 3x equals 3. Makes this whole part go away. So you would have 3 squared is 9 plus 1. So we have 1 equals 0 plus 3 squared is 9 plus 1 is 10. So you get that c equals 1/10. Now, the thing is, how do you make this go away? Well, you can't. So this, because x squared plus 1, that's always, you can never get a 0 out of that, right? Because negative 1 squared is a positive number. So if you plug in this 1/10, you get ax plus b times x minus 3 plus 1/10 x squared plus 1. So here what you have to do is you multiply all this through, bear with me, pup with me, and you get ax squared minus 3ax in algebra. So I'll let you make sure you can do this. Algebra is, I know, not always the easiest thing, but minus 3b, not 2b, or not to be, plus 1/10 x squared plus 1/10. Now, this equal sign means that here's the constant term 1. It has to equal the constant term over here, right? They're two polynomials that equal each other. So the constant term on one side has to equal the constant term on the other. The constant term over here is negative 3b and the 1/10. That's the constant. That is, it doesn't have an x in it. So let me rewrite this and group all my squareds and things together, just to make things a little nicer looking. The squareds, a plus 1/10 times x squared. The x terms go together, so I took care of those, and this one. I have a negative 3a and a b. And those are my x terms, so I took care of these. And then I'm left with my constants. Here's the constant term over here, and it has to equal the constant term over here. So we get that negative 3b plus 1/10 has to equal 1. And then you can solve for b. Also, what about the, how about what haven't we solved for? We know what c is. We need to know what a is. I guess I might as well just go ahead and solve for b here. The main thing is you can solve for b. Now here, what's the coefficient of the x squared on this side? The coefficient of the x on this side is a 0, and the coefficient of x squared on this side is also 0. So that means a plus 1/10 has to equal 0. And so a equals negative 1/10. Okay, great. And so you can plug them back in and do whatever you want to do with it, integrate or other things. That's the basic idea there. And then the fourth case is repeated quadratic factors. You might correctly guess that this is exactly like the repeated linear things where you just have another fraction for each power of your factor. So for example, let's do something more than just 1. 1's boring, I guess. There's another one. It's boring. You could have x squared plus 1 squared times x plus 1 cubed, say. So you need an x squared plus 1, and you need another x squared plus 1, then you'll need an x plus 1, then you'll need another x plus 1, and then you'll need one more x plus 1. Okay, and then here's an irreducible, that is, again, can't be factored, quadratic, degree 2. So we've got to put ax plus b. We have another quadratic thingy, so we'll do a cx plus d. This is linear now, like the main is, so this is just going to be one letter, one number. We have another linear thing. I mean, it's quadratic, but it's like as if you square it out, but it's just the thing inside the parentheses is linear. And then we have one more. And then you do a whole bunch of algebra mess. You can just go ahead and have fun with that. And so there you have it. Those are all the cases. You might wonder about what if you had a cubic down here and stuff. Well, long story short, because of algebra and theorems and stuff, you won't have to worry about that. If you do, you can probably factor it into a product of linears and quadratics. So having said all of that, I hope you learned a lot. I had a lot of fun explaining it to you. And I'll see you next time on Math with Taebyn. Bark, bark.